Hi everyone. So today we're gonna solve sliding window maximum using the third approach or using deque. So we already have a discussed two approach. It's two approach. As you can see, concept learned. The first approach is brute force approach, and if you try to submit this code on any platform, you get a TLE, and the time complexity come out from a brute force approach is big O of n square. And the second approach is using map. For this, we also return the code for it in a previous video. If you haven't watched, please watch it. And this is the code, and we have submitted this, and it got accepted. But in some other platform, if you try to submit this, I think you got a TLE. So for this, the time complexity would be using map, I am saying. So the time complexity for that would be n log k, and the log k comes from map. So we are using map. So log k time complexity for insertion and deletion. These two operation takes log k time complexity. So that's why it has n log k time complexity, and the space complexity it would be big O of k. So can we optimize this? Yes, we can optimize this using deque. Using deque, we can optimize, or we can eliminate this log k. So it the time complexity reduces to big O of n, and the space complexity remains in. So we are doing this. So let's start. So before moving to the discussion of this problem, approach of this problem, let's discuss what deque is, because the concept is going to use in this problem. So let's discuss deque, what deque is. So deque means doubly ended queue. If you have a little bit idea of queue, then it would be very easy to understand what deque is. So in a queue, what you will do usually, you have two ends. Let's call it this is a front. Assume this is a front. Imagine there is two end. I'm going to name it as a front, and this is back. So whenever you try to insert any element, you just insert from the back. This is insert, and whenever you want to pop from a queue, you will just pop from the front. So it will be delete or pop. So the elements come like whatever the first element comes, let's say A is come, then B, then C. Okay, so whatever comes first, it got popped out first. Okay, so this is the queue. This is queue. Now what is deque? So let me, okay, so let's say, okay, there are elements A, B, and C, D, E. So there are elements. This is deque, and how we will create a deque in C++. So it will be deque, and whatever data type you want, just write it and give it a name. Like let's say in this case deque. So this is the name of deque. Okay, in a deque, you can perform insertion operation and deletion operation at the any of the end. Like this is the back end and this is the front. So you can perform both the operation at any end. Like you can insert from the back and delete from the back, insert from the front, delete from the front. So this is the advantage of using deque. And as you can see, you can compare this like queue and deque, how they are different. Okay, so this is the difference. So how do we perform insert operation in a deque? So this like this, deque, name of the deque you have give, and deque dot push Where you want to push? Underscore back. So we want to push from the back, and the element that you want to push, let's say it is going to be F. So F. If you want to pop out, then you have to do this thing, deque dot pop back. We are going to pop from the back, and the same goes for the front. It will be deque dot front, sorry, it would be push, deque dot push front, not back, front, and whatever the element you want to push, let's say E I want to push, and for the pop, the same as for back, so it would be deque dot pop from the front underscore front, and this thing. Okay, these four operations are there, and one more thing is here. If you want to access this the front element, then you have to do this deque dot front. Whatever the front element are there, it will just print it out. Like in this case, the printout would be A. Okay, and if you want to back element, then you have to do this deque dot back. Okay, so these are the operation you have to remember for this question, and whenever you want to use deque, the simple thing is like just create an visualize this thing like this. You have two ends, front and back, and whenever whatever you want to push from the back or from the front, you just use the functions or something like that. Okay, so let's move to the question. Okay, so let me, okay, so before moving to the question, I will tell you to remember some of the concept so that it would be very easy to like you see the problem and you were able to solve this problem. So I am going to tell you something to remember. So uh, whenever, okay, so whenever you see deque is empty, let's say this is a deque which is empty. This is deque, and whenever you see an element, let's say uh, uh, 3 3 is the element you want to insert into deque. Whatever the element is, if deque is empty, just insert this. This is very basic thing. Okay, obvious thing. Let's say if deque is not empty, not empty, there are some elements. Let me write it. Oh, sorry. If you learn this concept, like the steps, you can say it would be very easy to solve this problem. Okay, so what I'm going to write over here is going to be 9, 8, and what was that? 2, 1, 4. So 2, 1, and 4. So these are the elements present inside this, and I want to insert 8. Okay, I want to insert 8, but as you can see, this is the deque. As you can see, the back element, which is this, imagine the front is this. One second, this is front and this is back. You are accessing the back element, so this is the back element you got, but you compare it with 8. As you can see, 4 is less than 8, so you have to popped out. Okay, let me tell you one more thing, what we are doing here, since it is like we are maintaining a decreasing order. The first element in this deque would be very high, and then it would be equal as well, 8, then 7, then 6, 7. So we are trying to maintain in this question, we are trying to maintain a decreasing order. So whenever it do not follow the decreasing order, then we have to popped out elements from the back. Understand this. We are maintaining a decreasing order. Okay, so let me erase this. I hope this is clear. So as you can see, if you try to insert 8 inside DQ, the 4 is, but you will ask like 982 is uh, decreasing, 1 is decreasing. Then okay, let's just erase this. So this is my bad. So this is erase this. Okay. Now as you can see, DQ is decreasing order, in a decreasing order. Now if you try to add 8 over there, as you can see, 1 is smaller, so we have to pop out this element. Now if you this popped out, then what will be there? It 2 is there, so t is again not following, so we have to pop out until there is no greater element. So 8 is also equal, so we have to pop out 8 also. 9 is there, 9 is greater than 8, so what we have to do now, just push it, like all the elements rather than 9 are popped out, and then I'm going to push 8 over there, so it will be front and this is back. So we are doing all the operations right now from the back. So now DQ is look like this after the insertion of 8. We have removed all the elements, there is one also, let me write it, and this is also got removed. Okay, but let's say there is one more case, that is 3. Uh, if DQ is not empty, DQ is not empty, okay, but okay, so this is this thing. This is DQ we have. There is 8, 9 as well, and 1, 2, and 1. So this is the DQ we have, and now I am trying to insert a smaller value. Let's say 0 is the 0 is the value I want to insert inside this DQ. As you can see, 1, we will compare this with 1 because this is decreasing. This is already decreasing. Let's say this is the front and this is the back. We are comparing the back element from the current element. We want to insert this 0, but as you can see, 1 is greater, so we will directly insert this. So after inserting, the DQ would be look like this. So 0 is inserted over there. Okay, so these 3 cases you have to worry, you have to learn. After learning this concept, the question is very easy now. Okay, so let's move to the question, and I'm going to take an example. So nums we have given is, I'm going to take the first example, which would be 1, 3 minus 1, minus 3, 5, 3, 6, 7. Okay, and this is 3, 6, and 7. So this is the array we have given, and k equal to 3 is given. Okay, let me do indexing as well. 0, 1, 2, 3, 4, and 5, 6, 7. So this is the indexing. Remember what we have done so far, like whenever we try to whenever we try to solve any kind of question which is under the category of fixed size sliding window, which is this question as well, it comes under the fixed size sliding window because the k is given and we have to find the sub array, so it comes under the category of fixed size sliding window. So in a fixed size sliding window, we do first step is to create a window, and the second step is to move window by adding and removing the elements. Okay, these two steps we are doing. So first of all, we will create a window using separate loop. So we are going to use deque. Let's say this is the deque. Initially it is empty, so The first loop goes like this. We will apply a separate loop from here to here. Okay, let me mark it with the green. We'll go to 0, 1 and 2. We'll take three elements because it is mentioned k equal to 3. So we will create a initial window. Okay, so we will go one by one. Okay, so we are at index 0 and as you can see value 1. 0 index has a 1. So deque is empty, just push it. Inside this, I'm gonna push the index and let's push the index, and certainly we will whenever we want the value, I'll just put like we can access it. If I know the index, then the value is like easy to access. Okay, so index I'm going to push is 0, and let me write it for a simplicity its value as well. So 0 index has a value 1. Okay, now move the pointer, and the pointer goes over here, index 1. As you can see, 3 value 3, uh, 1 is there back. This is the front. Let me write it front. Okay, let me write it with yellow color. This is the front and this is the back. And if you try to access the back element, you'll get a 1. And the current element, what is the current element you have? The current element I have is 3. So as you can see, 3 is the greater, so we have to pop this element. Okay, popped out. Let me pop this, and you'll get, now deque is empty. Now just push the element. So let me push this element, and the element is index 1, has a value 3. Okay, now move the pointer. Now my pointer is pointing to index 2, and index 2 has a value -1, and the back element has a value 3. As you can see, 3 is a greater, so we will just push the -1 directly. We don't pop any element. So just push it, and it would be index 2, and it has a value -1. Now my window is created. Now window is one for loop is applied, like all the three element has been processed. Now what we have to do, I want a maximum element from that window. Now I already told you, like in a deque we are maintaining a decreasing order. So can you tell me which element is going to give me a maximum? The first element from the front side. This is the element going to give me a maximum value. So what can I do? I will access like deque dot front. Since this is going to give me a index, I'll just decode it bit nums, and I'll get a maximum of it, maximum value of this particular window. So I will push it into a answer. So it would be 3. That's it. Whenever you create a window or generate a new window, you will get a maximum value at the front side. Okay, so let's do for the next 1 second. Okay, so now we are going to move my window. Moving window means you are adding some element or removing one element. Not some element, you are adding one element and removing one element. Okay, so this is going to be added, this element is going to be added, and this element is going to remove. We will come to removing element. First of all, let's add this element. So how we are going to add? We are currently over here, and as you can see, its value, what is the value of it's -3, and the what is the back element? It's -1. As you can see, this is the -1, this is the index, guys. This is index, and here I am representing the value of that particular index. So -1. As you can see, -1 is greater. minus 1 is greater and minus 3 is lesser. So we have to push this minus 3 over there. So let me erase this. Okay, after pushing the, what would be index, what is the index? Index is 3, and what is the value? Value is minus 3. Okay, now we have to remove the 0. So how we are going to remove 0th index? So it would be like, uh, this has a, currently pointer is pointing to, let's say this is the I, and we only include the element which is greater than I minus k. So it would be I minus k to I. This is my current window. Rather than whatever the index we store in deque, like I minus k, we will go to every, not every, we will try to figure out, like if my deque contains the index is less than or equal to I minus k. Let me erase this. This is deque index. Let me write it. Deque index. This I have to check. If my deque index is less than or equal to I minus k. If this is the case, from the front side, not the back side, from the front side, I will compare if my deque dot index, if my deque index, which whatever it has, is less than or equal to I minus k. If it is, then I have to pop from the front and pop until the condition is false, like deque index should be greater than I minus k. So we have to follow this condition. As you can see, there is no condition, like if you do I minus k, then I is my 3, which is pointing to this one. 3 minus 3, you will get a 0. And as you can see, there is, if you try to access the front element, you will get a index 1. And as you can see, index 1 is greater. So my deque index is greater. So we don't have to check for the next one, because next one is also going to be greater. Okay, so let me erase and do dry run so that you can understand better. Okay, so we are maintaining a decreasing order deque, and we are just moving the window. Okay, so we have created this one, this window. This is the new window we have, and now window is created. Just access the first element from the front side. That will be deque dot front, and you will get a 3 again. So put that 3 inside an answer. So this is the answer. Okay, now let's go, let's create a new window. 1 second here. Okay, let's create a new window. So let me erase this. This is the previous window we have represent in a green color. So the new window is this. By adding this element and removing this element, sorry, removing this element, we already removed this. We have to remove this because this is the previous one, this is the previous, and this is the new window we have added this element, and we have to remove this element. So how we are going to do that? First of all, let's add this. So we have currently over there, so it has a value 5, and as you can see, the last element has a value minus 3, and as you can see, this is the greater, so we have to pop out this has to be popped out. Let me pop. Okay, this is popped. Now we have to compare this element minus 1. Now minus 1 is also less than 5, so we also have to delete this element from the back. Okay, now compare this with 3. So as you can see, 3 is also less than 5. Now this thing is popped out, and as you can see, all the elements from deque is popped out. Now deque is empty, so directly push this 5 to inside a deque. Okay, so I'm going to erase this all. Okay, let me erase this. Okay, now my deque is empty, just push it, the current element. So the current element is index 4 and it has a value 5. Okay, now we have to remove this element where this. So we have to consider only this index. So this is I minus k, and we have to consider only that index which is greater than I minus k. So if you start comparing the indexes like 4 is greater than I minus k. What is I? I is currently over here. So 4 minus 3 is 1. So 1 1 is greater than 4, so we'll do nothing. Okay, just move the window now. Erase this. Okay, so my previous window is this. Now I'm going to create a new window. So I will do this. I will add this element and remove this element. Okay, so let's just add. So 3 is the current element, and if you compare it with the back element, you'll get a 5. And as you can see, 3 is a smaller, so we directly push it. So the index is 5 and the value is 3, so just push it, and we have to remove this. Now we will compare this. So this is the current index, so let's call it I, and whatever I minus 1, so I minus k is this index, I minus k is this index. So we will start comparing the indexes. Whatever the index we have inside a deque, we will compare it with I minus k. So this is my current window. Whatever the outside the window, we have to remove all the elements like I minus k. Whenever I'll get a deque index, this is, let's say, this is deque index, and if deque index is less than or equal to I minus k, that means deque index, deque elements. If this condition is true, that means some elements on a deque of deque are fall in this outside the window. So we have to remove this. So just apply this condition. This condition tells that there are some elements present inside a deque which is not from the current window. So we have to remove this. Okay. So as you can see, there is no element present. Uh, so just move the window. Okay, and we have to take maximum. How we will take the maximum? Just take the front of it, so it will be deque dot front, and you'll get 5. So put that 5 inside the answer. So we have to do the same thing, it's whole thing, like go to till the end, and you have to do the same thing. So the concept is very simple, like if your deque is empty, just push all the elements. Okay, light is cut off, so don't worry guys, just I am explaining. Okay, deque, if deque is empty, then push whatever element we have. Okay, the second thing, this thing, if my deque is not empty, there are some elements present. If the element comes, if my back element is less than the current element, then popped out until we get a higher value than the current element. So as you can see, my current element is 8 and the back is 1, 2, 8. So we have to remove all this until we get some value which is higher. And if deque is not empty and the coming element is very less, then just push it into the deque. Just we have to do this guys, and we are able to solve it. Okay, okay, so let's just go to the coding part. Okay, so let me remove this all thing. Okay, so let's just create a variable called n. This is going to store or size of the array. Now what we have to do, just create a deque of type integer, and let's call it deque. And first step is what? Create a window. How we are going to create a separate from the separate loop? It will start from 0 to k I plus plus, and we are going to check uh, while my deque is empty. If my deque dot empty, okay, if it is not empty, then what we have to do? We have to compare. Like if it is greater element, if my the current index, what is the current element? It would be I, array of I. If my array of I is greater or equal to, then we have to pop out from the deque dot back. The deque dot back, it going to give me a index, so I have to decode this. I want the element, so it would be array of deque dot back. Okay, whatever the deque has the last back value. If it is less than the current element, then we have to pop deque dot pop from the back. So it would be pop back. Okay, after doing this, then we have to push to the deque dot push from the back. What we are going to push? The index. Okay, after the initial window, this is the initial window. Let's create a answer vector. It would be answer. After creating this window, we want a maximum, so maximum would get answer dot push back. What we are going to push? The front element. So how do we access? deque dot front, but it gives me an index, so we have to do this num array of deque dot front. Okay, now the second step is move the window by adding and removing the elements. Okay, so we will start from int I equal to k. I is less than n, I plus plus. First of all, let's just add. How we are going to add? The simple thing is do this. Copy this and paste it over here. So we will check if my deque is not empty, then I'll try to compare this thing with back and the current element. If the current element is greater, then we have to pop from the back. Now we have to remove. So we will compare while my deque dot empty. If it is not empty, then I have to compare I minus k should be if my array of deque dot front, if my front index is less than or equal to I minus k, then I have to pop deque dot, because it is the outside the elements present inside the deque, it's outside the from the window, so we have to pop out. So it would be deque dot pop from front. Okay, after doing this, we will just push. Let me push over here. So it is going to be deque dot push from back and the index. Okay, after the new window is created, this is the new window is created. This is new window is created. So we have to take the maximum of it. So answer dot push back. What we are going to push? Array of deque dot front is this is going to be give us index, and just push it to the answer. After that we have to return answer. So let's just create, let's just run this. And as you can see, this is accepted for the test case, example test case. Okay, so we are getting a wrong answer, where I'm getting a wrong answer. Okay, so k is equal to 1. Mhm. If my array, we are comparing this thing, array of I, okay, uh, pop element, and yes, we are good. I'm going to n. If my array of I is this, we have to pop. Mhm, mhm. Array of I and array of, okay, pop back, okay. While deque dot empty, not empty, array of front, I will check if my array of front is less than or equal to I minus k, then I have to pop from the front, okay. Then I am accessing the front element, deque dot front, okay. That's also correct. Why I am getting, okay, let's dry run, and I'm equal to -1. So we are just creating a window. So 0 to 1, deque is empty initially, so we'll push the 1, and yes, we have completed. Then 1 is going to be answer, okay. So we have to uh, add this -1 over deque dot pop, -1, okay. So we will check if my -1 uh, is lesser, so we don't fall this in. We will just push, okay. deque is empty, array of I minus k, I is what, 1, 1 minus 1 is 0. So we'll check if, okay, so we have to not compare the value, we have to compare only the index. So this is the thing. Okay, let me submit it again. Okay, this is accepted, and if you try to analyze the complexity, so let's see the time complexity, and the time complexity would be big O of n, and the space complexity for this is big O of k. So this is the question, guys, and we have solved it. So let's me mark it as a done. So in the next video we are going to start a sliding window, variable side sliding window. So see you in next video. Thank you for watching.